Okay, so let's start. So last class, guys, we were talking about cash flows. If you remember, we were talking about cash flows, okay? Why is not fighting? Ah, here we go. We were talking about cash flows. So basically, cash flow looks like this, right? So I have an output of money, then I can have, let's say, inputs of money. Got it? And one technique that we're going to be using based on the cash flows is something that is related to the net future value.
Professor, if you're writing, it's like your screen is not shared unless you're setting up.
Same for
Oh,
me as well.
yeah. Okay. So perhaps I'm not sharing. Yes, haven't started sharing. Here we go. Okay. So I don't know why my computer is very slow. Give me 1 second. Yes. Do you see now?
Yes.
Okay, perfect. So remember, guys, I was telling to you last week, we used the concept of cash flow. So we know how to compute cash flows, how to move the money from the present to the future, future to the present. Okay. And now, based on the same concept, what we're going to be doing now is computing what is called the net future value and the net present value. They are heavily related, a net present value. Makes sense? So this is a net future value, and this is the net present value. So what is the idea here, guys? This is normally used, these two concepts are used for something that is called project evaluation. And the idea is very simple. So let's assume, for example, let's put some numbers here, okay? Let me clean this part here, and let's put some numbers in here. So let's assume a very simple example that allows me to work with MATLAB very quickly. I have $1,000, and I will receive, imagine, $500 in 1 year, and I will receive $1,500 in 1 year. Got it? So you invest $1,000 and you're going to receive $500 in 1 year and $1,500 in the second year. So the idea is, do I do this project, yes or no? That's the question. So this here comes to be a simple exercise of bringing all the money to the present. This is net present value, or bringing all the money to the future. This is net future value. Agree? So what is missing here, guys? Very quickly. What do I need in order to do even discounting or compounding? What do I need?
The interest rate?
Yes, the interest rate. Correct? And the interest rate in this particular case, guys, is something that is called the opportunity cost. Okay, so what is the definition of opportunity cost? Someone? What is opportunity cost?
Oh, is it essentially that if we don't put it into this project, like if what would be missing out if we put it into this project? Because it would be 1,000
right.
times the interest rate otherwise, one
Right.
plus the interest rate.
Exactly. So basically, the opportunity cost, guys, is your best opportunity not being this project. Okay? So is the return of your best opportunity that you have not considering this project. Okay, let's assume just for easiness that this is 10%. So what is the meaning of 10%? Is that you have another alternative, whatever alternative, that you can create 10% per period. Okay, and this 10% must be realistic, guys. So it means that you need to have a project that indeed produces 10%. Got it? Okay, so now let's go and talk a little about the net future value. The net future value, guys, is simply I move everything to the future. So imagine I want to move this 500 to the future. So this implies that I will invest this 500 at my opportunity cost. So I will have here 550. These two cash flows are in the same period, in period 2, so I can sum them up. So in total, I will have 2,050. Make sense? Just taking a look to the inflows, we can make 2,050. Now, the second thing, forget about everything that is on top. Now just take a look to what happens with $1,000. So if you don't have this opportunity, guys, this project here, you can put this $1,000 at what interest rate? If you don't have the project, at 10%, do you
10%?
agree? Exactly. So it's going to be 1.1. How many periods? Power 2. Got it? Can you help me with this? How much is that? I don't have my calculator here. Well, so it's going to be 1,000 times 1.1 squared. So this is equal to what?
1,210.
1,210. Now, if I subtract this minus this, okay, so I obtain 0 for 840, correct? So what is this 840? So first the intuition, guys. What is this 840? So what I'm comparing is what? What my project produces versus what I produce at my opportunity cost. So this difference here, guys, is the difference versus what the project produces versus what you can be producing with the opportunity cost. Make sense?
Is that net future value or no?
Exactly. And this one here, as soon as we're moving everything from the present to the future, so you see, we're moving from the left to the right. This is called the net future value. Now, what is the decision rule with the net future value, guys? If the net future value is greater than 0, this is good or is bad? It's good, right? Because your project is producing more than the opportunity cost. So if the net future value is larger than 0, so basically do the project. Make sense to everyone? Okay. Now the net future value, guys, of course is correct. The issue is that very few people uses the net future value. So what the people use is what is called the net present value. So what is the idea of the net present value? Well, the net present value, as its name says, what you're doing is going to bring everything from the future to the present. Got it? So what I will do is my net future value is going to be, my net present value is going to be minus 1,000. Nothing to do here because already times 0. And what I will do is I will bring my future dollars into the present. 500, one period to bring it to times 0, plus 1,500 divided by 1.1 to the power 2. Correct? Make sense? Can you help me with this number
Yes.
here?
Is it 694 and 21 cents?
Okay,
Can someone else confirm?
694 and 21 cents. Someone to confirm?
I got the same thing.
Perfect. So let me.
Just a quick question. We can do the net future value divided by the 1.1 squared as well, right? Like we
Yeah.
can bring it back that way.
Yes, of course. And this is what is called the net present values. Okay, sorry for that. Give me just 1 second. And this is called the equivalence equation. Okay? What Lauren has mentioned to you guys is, do you see these two numbers? The net present value. Oh, so the rule, first of all, if the net present value is larger than 0, so you do the project. Correct? Makes sense? Because you're making more money than what you're investing. Now, Lauren mentioned something that is crucial, and it's called the equation of equivalence. NPV is equivalent to net future value. So what is the meaning of that, guys? Is that, can you see the numbers? 840, of course, is not equal to 694. But if you bring the net present value to the future, so for example, net present value to the future. So what I will do is simply 694.21 multiplied 1.1 squared. What you're going to obtain, guys, if we have done our estimations correctly, we're going to obtain 840. Do you see? This is my net present value. Just transform, move to the future, should give me the future value. Or, if you prefer, the net future value, move it to the present. So this implies that I need to do 840 divided by 1.1 squared should give me the present value. So this is the meaning of equivalence. Make sense to you? Perfect. So when we have project evaluation, we have net present value, net future value. If these two numbers are larger than zero, so this implies that the project is good, it's better than the best opportunity, better than the opportunity cost, so you do the project. There is an additional term that we're going to be using all the time, guys, that is called the internal rate of return. Internal rate of return. Or simply the IRR. Got it? So mathematically, what is this? So the intuition of this one here is this is my average interest rate per period. Interest rate per period. Generated by my project. And mathematically, guys, it is the interest rate that makes the net present value equal to zero. Got it? So if we want to solve this one here, I know that my present value is, I want my net present value to be equal to zero. And I know the formula is going to be minus 1,000 plus 500, 1 plus internal rate of return, plus 1,500 divided by 1 plus internal rate of return squared. Basically, this is one unknown, one equation. You can solve it, but you have power too. Do you agree? So this is a quadratic equation that you need to solve. But we're not going to do this using by hand. We're going to use MATLAB for doing this stuff. Make sense to you guys? So this is what we're going to be doing first with MATLAB. And I will start using, guys, MATLAB commands already, okay? Financial commands that are going to help us to do this stuff. Got it? Make sense? Okay, so let's start working with, let me go to MATLAB now. Do you have MATLAB? Okay, the first thing we need to do, guys, is introduce the cash flow. So my cash flow was equal to, I need to introduce this in, how do you call it? Matrix form. So this was minus 1,000. 500, okay, minus 1,000, it was 500, 1,500. So this is my cash flow. Got it? Okay. So in order to find my net present value, so let's call this NPV 1. The MATLAB command, guys, is going to be present value var, PV var of your cash flow of CF. So this is the name of the variable that I'm simply assigning to this. PV is the present value. And var is, this is the MATLAB command of your cash flow. Now, what you need, guys, is your opportunity cost, 0.1. Make sense? Make sense, guys?
Just a quick question.
Yes.
This opportunity cost is not the same as the internal rate of return.
No, 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 no.
Okay.
Oh, yeah, you know what? There is
Yeah.
something missing, guys.
Yeah.
Yeah, there is something missing. There is a decision rule with internal rate of return. So what is a decision rule with an internal rate of return? So this is an interest rate. Do you agree? So this internal rate of return, you're going to compare this versus what? What in this cash flow or in this part here is a percentage? The opportunity cost.
The interest rate?
Yeah, the opportunity cost, this one here. Do you agree?
Yeah.
Okay, so the logic is if your internal rate of return, so this is the percentage return that your project produces, is larger than opportunity cost. This is good or bad for the project? What do you think? So the internal rate of return, remember guys, is the average interest rate per period generated by the project. So imagine this is 20. Okay, my project produces 20%. My alternative produces 10%. Which one is better?
Oh, you should do the project then.
The project. Do you agree? So the decision rule in this case, guys, is going to be this one here. If this happens, then go with the project. So we have the decision rule of the net future value. And then we have the, oh, here also. Well, and then here we have my decision rule with the net present value. Makes sense to you guys? Do you understand this?
Yes.
Perfect. Okay, so now let's go to MATLAB again. And you see, take a look. 642149. The number that we got before. Now, if we want to compute the net future value, instead of P, what goes? Future. Make sense? Here we go with my future, 840. Sorry. I should have changed the names. This is present. And this one here, I will change this, okay? The name. Net present value, net future value. Yes, okay, just the names, just to keep them independent variables. And now, what is my internal rate of return? How do I compute my internal rate of return? I will call it IRR1, and the MATLAB command is simply IRR of what? Of my cash flow. Make sense?
Yes.
Okay, so we run. And here we go. I know my computer is very slow. 50%. So what is your decision rule, guys? 50% is larger than 10%, so you do the project. In terms of the net present value, larger than 0, do the project. Net future value, do the project. Okay? Can you create one table that is called summary? And it will have net present value, net future value, internal rate of return. These three values. How do you do that? How do you do that, guys? I want to put all the results in a matrix. Do you agree? Well, in a vector in this case. Correct? So how do I tell MATLAB that we're going to be working with vectors? We need to do the brackets. Okay, so this is what MATLAB understands. Oh, my user is telling me to create a vector. What is going to be inside the vector? Well, I want the net present value 1 that I call it here. I want the net future value 1, and I need the internal rate of return 1. Make sense? Make sense, guys?
Yes, Prof.
Yes.
Then if you enter here you have the results. Questions? No questions? Okay. So now what you're gonna do is the following. We have this example. Now you have another alternative, another project. Okay, this other project, guys, has the following cash flow. You invest also $1,000, but here you produce 1,200, and here you produce 800. Okay, the opportunity cost is the same. Everything is the same. So what I want is first build a matrix. So remember you have here NPV1, NFB1, internal rate of return 1. Do now NPV2, NFB2, and internal rate of return 2. So create this table here and tell me which project is better, is best. Okay, 2 minutes to do this. Ready? Guys, remember you need to use the arrows, up arrow, so you just go to the formula, change the name of the variable, change the name of the cash flow, and that's it. You need to call your cash flow a different cash flow also. So don't call it CF, call it CF2 or something like that. Just to keep track of what you have in there. Let me 1 second, guys, while you do this. Ready, guys? Are you with me now? Okay, so
Yes.
let's do this. Okay, so I go. Sorry, I need to see my cash flow. Is 1,000, 1,200, and 800. So I will define another cash flow. So let's take a look to the cash flow, the original one. So this is called cash flow 2, 1,000, 1,200, and 800. So this is my other cash flow. Do you agree? Now I can compute the net present value, net present value. Okay, so net present value, I will call it 2. It's going to be the present value of cash flow 2. And the opportunity cost is the same. I will just put semicolon, okay? Just not to be printing out everything. And then I will go to my net future value 2. That's going to be simply the same formula, but for cash flow number 2. Correct?
Yes.
Well. And then what I need is the internal rate of return 2 based on cash flow 2. Agree, guys?
Yes.
Okay, so here I need to show you something. The summary. You know the summary is already this one here. How do I append 3 more rows, 3 more columns below the first row? So I know that sum is this one, correct? Can I do the following? I know that sum is the first column. Sorry, I need to have this. I will just write sum up. So if I do this, I'm doing what? Nothing. Agree? But what I can do is the following. I do, okay, take the previous summary and then append on the bottom, what's the name? NPV2, NFB2, internal rate of return 2. You see what I'm doing? I'm appending more information to something that already exists. Okay, so this part here, guys, is crucial. Do you understand what I'm doing? So imagine if you have a vector already, a matrix. So you want to append something more, you copy the same matrix. So sum is going to be sum at the beginning. And then below that, so remember the semicolon puts one row below this information here. So you need to present this one here in terms of a bracket. And here you go.
Okay, Prof, is there a way of appending the column only and not the row?
Yeah, you
Like
can.
if wanted. Okay.
Yeah. Instead of semicolon, comma.
Okay.
Simply comma. Makes sense? You
Okay.
need to be
Yeah,
sure,
that
of
makes
course,
sense.
the dimensions, right? So if you're going to append a column, it needs to have that. It needs to be one or many columns, but the same number of rows.
Yes.
Okay, guys. So which project is better? Just
The second project.
using the NPV. Which one is better? NPV, remember, is the first column, right? So which one is better? The one that
The
has
second
the
one.
highest NPV, or the
Yeah.
highest NFB, or the highest internal rate of return. So basically, guys, the second project is your best project. Do you agree with me?
Yes, Prof.
Questions?
Dr. Ng, you've had a question. So
Yes.
for rate of return, I know it has to be higher than opportunity cost, but there's no like minimum requirement, right, of how much bigger?
No. So you mean what is my opportunity cost? It's something that you should have. Okay, so that the opportunity cost comes from your business, Alfredo.
No, yes, but you said to push through the project, rate of
Yes.
return has to be higher than opportunity cost. Is there a
Yes.
minimum of how much higher or not necessarily?
No, not
Okay.
necessarily. Not necessarily. You know, one assumption that we are doing here, of course, guys, is that two projects have similar risk coefficient, similar levels of risk. Do you agree?
Mm-hmm.
Because if you
Yes.
tell me that one is riskier than the other one, so what needs to change in your analysis? There's one variable that needs to change. the opportunity cost.
Yeah.
Okay, because remember, you need to penalize more a project that is more risky. The only way in which you penalize for something more is simply moving the opportunity cost. In that case, the opportunity cost is not only what you can get, but also is a penalty for more risk. Got it? Makes sense to everyone?
Yes, sir.
Perfect. Okay, questions?
Oh, so Prof, last one. To
Yes.
compare a project, you have to look at either the present value, the net present value, so you can
It's
use
or.
either of the three.
Yes,
Okay.
because remember, they are equivalent. Seriously, the net
Okay.
present value never goes against the net future value because they are equivalent. You're
Okay.
talking about the same exact thing. Makes sense to
So
you guys?
if the net present value and the net future value are not there, you can use the internal rate of this the interest rate, the one that you showed us, the IRR.
Yes. So
Okay.
always
Thank
go
you.
for a net present value. The net present value is the
Okay.
best. Well, net present value or net future value because they are exactly the same. Okay, they are equivalent. They are not the same mathematically because the numbers are different, but they are equivalent. So this implies that you can use either. You don't use both. You use one. Normally the net present value.
Thank you.
My pleasure. Okay, guys, questions. So we can move to something more.
Yeah,
Yes.
just one question. The internal rate of return, it can be like 1 point something, right? Like that's like really large,
yeah.
but that's possible. Okay. Thank you.
Yeah,
Okay.
you know what the problem, what we have, the problem that the internal rate of return has, or the problem that it has, is that if you have multiple changes of sign, so imagine you go down and everything is up, that's perfect, or up and everything down in cash flow terms. Also, IRR is correct. But if you have change of signs more than once, so imagine you start one down, then up, 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 down, then up again, for example. So there are multiple changes of sign, IRR can fail. So that's why always the net present value is the best one. The internal rate of return, be careful. The net present value never fails. Got it?
Yes, thank you.
Okay, perfect. So now let's go into a new concept that you need to know in finance. So let me save this one here. Let me open a new one. Okay, guys, so we're going to do something very quickly, and then we're going to start putting together a lot of things, okay? You're going to see, in terms of programming, you're going to understand how this works very easily. Let's do something that is called amortizations or annuities. I will not do all the mathematics, guys, but let me tell you how this happens. So imagine, guys, that you have my C0. So you get a loan for a car, and then you're going to make payments. And then let's say that you're going to make end payments. Got it? So you receive, and the payments are going to be constant. Make sense to you? So that's the idea. So how do you find the present value? How do you find C0? Let's call this present value. Okay, or my principal normally is called also. Okay, P. So guys, P is going to be equal to PMT 1 plus I to the n minus 1 over 1 plus I to the n times I. Okay, the math is very simple. I think I have some class around there that I will share this with you. But this is the math. But normally you don't care about the P. You care about this is the money that we'll get. I'm caring about how much I will pay per period. So you care about the PMT. I will put this PV, okay? The payment is going to be PV that multiplies 1 plus I to the n, times I, divided by 1 plus I to the n minus 1. Okay, so let's do extremely simple example. PMT, I want, let's say, $5,000. Let's say that my N, I will return this one here in 4 months. Let's say that, what else? Oh, let's say that my interest rate is 8% per year. Then what is my, sorry, I have NM. My question to you guys is, what is my payment? How much I will pay per period?
Or visit payment or the present value?
No.
Yes.
This is the, sorry, you're completely right. This is my present
Okay.
value. This is my present value or my principal, my loan. Okay, so this is basically a loan.
Okay.
Okay, so the first thing you need to know, guys, is in order to find this part here is called a factor. The only thing that you need to be very careful here is that N is in 4 months. Do you agree?
Yes.
But I have a rate that is annual. So the first thing I need to do is what? I need to compute the interest rate per month. Do you remember how do we transform interest rates?
Yes.
It's going to be
The
1.08 exactly to the power of something minus 1. What goes up?
for
No. I need monthly because I will make 4 payments,
yes.
but I need to have the monthly interest rate.
Oh, is it
Got
1
it?
over 12?
1/12.
Okay.
Got it? Once you have this number here, guys, okay, you compute this number, then you can go and compute your factor. Okay, your factor is going to be something. Someone can help me. Give me 2 decimals, rounded, no, not cut. 108 to the power 1/12 minus 1. Someone can give me this value.
I got
No,
zero
it's
0.006.
0.006. Give me more decimals. Can you give me
4.3.
4.3? Okay, perfect. So this is my number. Got it? So now my factor is going to be, and here, please help me with the calculator. Then we're going to do this in Excel, and then we're going to do this in MATLAB. Got it? So you're going to have the complete picture how this works. And this one here, guys, is crucial for a lot of things that we're going to be doing in programming. Okay? This example is really, really good. You're going to see. But I need to go step by step so you can understand how things work. So my factor is going to be 1.00643 to the power 4. That multiplies 0.00643 divided by 1.00643 to the power 4 minus 1. Okay, can you compute this factor, please? And once you have the factor, guys, you can compute the payment, correct? The payment is going to be your PV times the factor. So your PV is 5,000 times this number that you get here. Okay. 2 minutes to do this. I will pause the recording.
Professor, I just have a question.
Yes, go ahead.
What do you mean by factor in this?
Oh, it is called the factor. All this part here,
Mhm.
all this part here, all this formula here
Mhm.
is called the factor.
Okay,
It's
so
just a name.
a name. Okay,
It's just
I
a
got it.
name. Yeah, it's
Okay.
just a name.
All right, thank you.
Okay, so remember, if you perhaps even up to the 70s, 80s, if you went to a bank, you need to go physically, right? You don't remember those times. I remember those times. You need to go physically to a bank, and then if you want to go, for example, if you have you want a loan, okay, and the loan had different interest rates. So you know how the banker know how much you're gonna pay, because the normal question for you is, okay, how much I will pay? Do you agree? So they went to book, and then in the book they see, okay, n periods, interest rate per month, and they found the factor. It was do you remember, guys, the normal distribution tables?
yes.
Do you remember the C tables?
Yes.
It was exactly the same. So you have here n, 3 months, 4 months, 6 months, whatever, and they have the interest rate here. You cross them and you find the factor. And this banker took the factor and multiplied times the money that you wanted, and he computed your PBs, your payments. That's why it was called factor. Okay? So give me the numbers. 2 minutes, and allow me 2 minutes. Bring some water. Okay, guys, do you have answers? Guys, answers?
So I got for the factor, I got 0.254.
0.254. What else? A little more?
0.0316.
Oh, that's good. 0, that's okay. Someone to confirm? 0.254?
I got the same thing.
Perfect.
Yeah, I did
Then
too.
in that case, it's easy, right? You multiply, you put this factor here, and what do you get? What is going to be your payment?
1,270.158 or 16.
Yeah. Someone to confirm?
I got 1270.70. It was like
Yeah,
696.
that's
I don't know
okay.
if that really matters if it's the decimal.
No, it will. MATLAB is going to be so precise, and Excel is going to be more precise. But we have the idea. Okay.
Okay.
So this is my payment. Make sense? So now when you go to a bank, you also request for something that is called the schedule of payments. The schedule of payments. So how the schedule of payment looks like, okay, there is some slight variation. So you have here, let's say the month. So you're going to have 1, 2, 3, and 4. You have here the principal. You have here the amortizations. Amortization, remember, guys, is simply the payment towards the principal. You have the interests, and then you have your PMT. Got it? Follow me for a minute, and then you're going to complete this table very quickly. So my payment is always going to be 1,270.16. Okay, let's read it like that. It's going to be 1,000.16, 127.16, and 1,270.16. Got it? It's the same. Now, my principal at the beginning is going to be the amount of money I got from the bank. What you need to compute, guys, first of all, is the interest. So how do I compute the interest? I need to pay $5,000 times my monthly interest rate, this number here. Can you help me? I will put this one here. This one here is 5,000 times my 0.00643. Can you give me this number? Help me with this number. So it is the principal that you owe at the time times the monthly interest rate. And you get what?
32.15.
82.15.
30,
Perfect.
no, 32.
Oh, 32. Yeah,
Yes.
let me delete this part here. 32.15. Confirmed? Yes, perfect. Okay, then the amortization, guys, is always the difference between the payment minus the interest. Amortization is the payment minus the interest. Okay, so can you help me? What is 1,270.16 minus 32.15?
1238.01.
Perfect. So how do I compute the next period? It's going to be 5,000 minus 138.01. What do we get here? This minus this gives me my new principal. Can you help me with that?
3,761.99.
Perfect. And then you continue doing the same stuff. Can you complete this in 3 minutes? You compute the interest rate first, then the amortization, then you have the new principal, etc. Okay, let me pause and I will open an Excel to do this stuff. Okay, one more minute, guys.
Hi, Professor. I have two questions, one relating to
Yes,
this and one from last
Lauren.
section. Okay, so if we get to the final payment and it's like it exceeds the remaining amount, you just pay the remaining amount,
No,
right? Or am
no.
I doing something
There
wrong?
is a there is a mistake there.
Okay.
Okay, that's one of the checks. The remaining amortization must be exactly the same as the principal.
Okay,
Perhaps one of
okay.
don't worry about that. We're gonna do this in Excel and then in MATLAB. So you're gonna see the
Okay,
exact
got it.
numbers. Okay, but you should have
Cool.
some mistakes somewhere around there. Okay, let's do this.
All right.
Let me record this one. Okay, guys. So what is the second interest rate?
I got 24.19.
Someone to confirm?
Yes, I got the same thing.
Perfect. What is the amortization now?
I got what?
Oh,
Okay,
go ahead. Go ahead.
go ahead now. Okay, so I got 1,245.97.
I got
Okay,
the same thing.
perfect. So what is my new principal now?
2,516.02.
Perfect. My interest?
16.18.
16.18, confirmed? We're gonna confirm this later, okay? So what is my amortization?
1253.98.
Perfect. And then finally, what is here? My new final principal?
1262.04.
62.04. Okay, my interest?
8.11.
8.11. And my principal? Should be very,
1262.05.
yeah, very close
got.
to this one here. So this is what, Lauren, this number here must be equal to this number here.
Got it.
Because
Okay.
the last period, what you owe is exactly what you want to pay is exactly what you owe. Make sense?
Yes, thank you.
There was a mistake somewhere out there. Okay, makes sense to you guys?
Yes.
Good.
So
So
just a question, Prof.
yeah,
When you add all the amortization, they should give you the initial 5,000.
exactly. Yes.
Okay.
If you sum all these numbers here, because you cannot pay more, right? You pay the exact principal. What happens is you're paying interest. And in this
Okay.
method, guys, as you can see, the interest at the very beginning are high, and then in time they go down. Okay? And you're gonna see this happens, guys, when you buy your homes, you buy your apartments, you buy everything. At the very beginning, almost everything goes to interest. So you're gonna see how painful it is. You're gonna see it in a couple of minutes. Make sense to you?
Yes.
Okay, so let's go and let's do the following. I'm doing this in Excel. You see Excel? So
Yeah.
my data, present value, $5,000, annual interest rate, 8%, the number of months for my monthly interest rate is what we have done is 1 plus 8 divided by, sorry, to the power of 1 over 12 minus 1. Here is your 0.06. Here's more decimals, of course. Then your factor is what we have done, the 0.54034, etc. And my payment is 1,270.17. Make sense? This is what we have done. I will share with you this Excel later. Don't stress with that. Just follow me, okay? Because I want to have Excel to check with MATLAB. That's what I want. Okay? We're using MATLAB, so not Excel later. So I do the same, my balance, my principal or amortization, my interest, and my payment. My payment is going to be the same. And then I compute my interest. That is how much I owe you at the bank times the interest rate, monthly interest rate, etc. And so we have exactly the same results as before. Make sense to you?
I have a question, Professor.
Yes, go ahead.
For interest, is it normal for it to be like a pattern? So it's like 8, 8, 8. Like it keeps going down by 8%.
Yeah, it goes, yes, because there is a pattern because these numbers here are also related to the periods.
Okay.
Okay. Yes, but it's not necessarily 888. Huh? If you take the difference here, not necessarily true. So this one minus this one is 797. You see? They are very close to each other, but they are not exactly the same. So you cannot basically do this minus this number minus, you cannot use this number here to subtract from everyone.
Okay.
Okay.
Thank you.
Okay, so now let's go into MATLAB. Let's open MATLAB again. Again, what I will do is I will introduce my variables, okay? So let me clean. Can we clean our workspace? Well, I will need this for saving later, but let's do. So let's say, let's do one more complicated. Well, it doesn't matter. So let's do PV. So let's enter our variables. Let's say PV was $5,000. Do you agree? I think my interest annual was 8%. Then my, what was that, periods? We said was equal to 4, right? The only thing that we need here, guys, for MATLAB is to give the interest rate for the periods that we're going to be using. So if we use monthly, we need to compute, let's compute it my I monthly. That's the only thing that I need to compute here. I monthly is going to be equal to what? It's going to be equal to this one. I'm sorry. 1 plus this number to the power 1 over 12 minus 1. I need one more parenthesis here. Make sense to you?
Yes.
Okay. So then how do I compute which command I will use? Let's do this. The MATLAB command is called amortize. And what I need is simply my I monthly, so the interest rate, and my PV. Now, this is going to return a lot of things. It's going to return my principal. Let's call it, these names are up to you. The principal. It will return my interest, okay, my balance and my payment. These names, guys, you can change them as you want. But this function here, amortize, just needs the monthly interest rate or the period interest rate, the amount of money you're going to lend or get as a loan, and we're going to get all the information that you want. What's going on here? Oh, let me check.
I think you're missing the number of periods because I put in the same thing as you got
Oh,
monthly.
so let's go help. You know, if we have problems, let's do this. Help amortize. Yeah, oh, yeah, number of periods. You're completely right. So we forgot. Thank you, Lauren. So it is going to be, let me check. So my schedule is, yeah, rate, number of periods, and PV. So rate, how do I call my number of periods? Periods, monthly, periods, and PV. Agree? Okay, so, oh, yeah, that's okay. So what we call here principal is indeed our amortization. Interest is interest. Balance is my principal. And my payment is my payment. Okay. So now, guys, take a look to these results here. I want you to build the exact table as we have built here. So the month, so let's call this month. The balance, the principal, the interest, and the payment. Make sense? I want you to build this table. You have all the information. So the principal is what we call amortization. The interest is the interest. The balance is the balance. But you can see that the balance starts with 376. Take a look. So it starts in here. So you need to, and ends in 0. So you need to introduce to this one here. I want this to start at 5,000 and not end in 0. And then the other thing that is interesting, guys, is that you have the payment is a single number. So you need to replicate it several times, right? So you know the rep math. Okay? So you have 2 minutes to create a table, guys. You have all the inputs. I want you to create this table here. Where's my table? This table here. 2 minutes. Ready? You were able to build the table, guys. So for mounts, let's call it M. So what do? I want to create from 1 to 4 in a vector, column vector. How do I do it? So I will call this M. Oh. Sorry, I need to be here. M is going to be equal to what? No, why is it not here? What I have done. Give me 1 second, guys. I need to be sure I haven't destroyed anything. Yeah, I think it's okay. So I will define M as what? I just want the first part, the first column is 1 to 4, right? So it can be 1 to 4. The issue is that when we do sequences, they are always in a row way. So what I need to do is I need to put this first as a vector, and then I can transpose it. Correct? Okay? So I have the first
Yes.
one. So now I need my principal. The principal here is what is called balance. No, sorry. It's a balance. Do you agree? I call it balance or not? How do I call it? Balance. Yeah. So what is the issue here? It's also a row, and I don't want this number to be 3,000. I want this to be the principal, and I want to disappear this one here. So I can call this balance adjusted or auxiliary. You tell me, guys, how do I do it? The first one is going to be my PV, right? Correct? And then after that, I want all the elements from 1 to 3 of balance transposed. Balance 1 to 3. 1 to 3. This one here transposed. Yes or not? So here we go. I have my what is called principal here. These are my payments, correct? My amortizations. So this is okay. The only thing that I need to do is transposed. So what is missing? The payment. I will call it PMT. So, and the payment, guys, how do I call the payment here? Payment. It's called payment. I call this payment. I want this to repeat how many times? I'm sorry. I need to repeat this. Rep math. Remember this command. I want to repeat this one here. How many times? How many times?
4 times.
Four rows. Do you agree? Okay. So what I can use is what? If I want to use the size of what? Let's say size of amortization, comma 1, comma 1. Do you agree? Amortization, guys, the one that I have created here, has 4 rows. So I will repeat this 4 times 1. So I have this one here. And then finally, I can create my summary table that is going to be equal to 1, my month. Next to it, I write my where's the one that I modified? This one here. Oh. My summary is going to be equal to M. My payment, no, not my payment. My val aux. Then my, how do I call it? Amortization. Then, what is that? Interest. Where is my interest? Where is my interest here? Interest, I need to transpose this to. And then finally, my payment. Do you agree? Guys, make sense to you?
Yes,
Now, I
sir.
don't like this format. I want the format bank. Then I can print my summary. You can see the numbers are exact, the same numbers as we got in Excel or whatever. Do you see, guys?
Yes.
Okay. Now I send you one file that was called my amortization B0. Do you have that? I sent you one M file that is called my amortization B0. Can you open from your email? You see that?
Yes.
Can you open in MATLAB? So you're in an editor, open, and then you select the file and open the file. Looks like this. Do you have the file?
Yes.
Yeah.
Okay, perfect. So this is a file that we cannot do. Sorry, why is this one here? This is the one that you're gonna do later. Yeah. Yeah, there is a lot of things here that you cannot do, guys, but let's ignore this for a minute. Let's ignore the first part, okay? This is done by hand. Let me explain what this program is doing. Basically, you have the data. I have $10,000, 5% per year. It's monthly 12 payments. So let's do this 1 times 12. Okay. Monthly, this is your interest. This is your factor. You see the factor here? The one that we have computed. Then I can compute my payment. I know why I'm repeating this stuff here. Sorry, guys. Why? Yeah, I don't need this one here. It's already repeated. Yeah, and then we can build by ourselves. This is going to be an exercise for you later, guys. Using the for loops, if else loops. You're going to do this later. Ignore this for a minute. So let's go to this point here. This is what we have done. Principal, interest, balance, payment, amortized, blah, blah, blah. The payment table, I need to remake the payment, the balance, the format, etc. And then I do some graphs here. What I do, I think I have done something in my program that sorry, but I need to clean this part here. Plots, calcs, I don't need all this part here. Let me delete this one here. I don't know. Okay, so this is what we have done here, guys. Do you see that?
Yes.
Okay, so ignore this one here. That is going to be assignment for you later. You're going to see that. Okay, so if we want to run, so let's save this one here. If I want to run this one here, up to here, you just click in 56. Or in when it says plots, can you just identify plots and just click where it says plots in the 56 or whatever number that you have? So this is telling MATLAB, do everything, stop here. Okay? And then do we have, right, this one, $10,000, 0.05, 12 periods. I really don't need all this stuff. Sorry, guys. But I want to be sure that I'm not destroying this from somewhere else. Do I have another my amortization? So let me check this one here. I was preparing this for you. Okay, calcs. Oh, this is the one. Yeah. So I think I destroyed the wrong one. This should be the first one. Well, ignore this part here. So let's run. Let me. I don't need this one here. I just need this part here. Yeah. Okay. So we have $10,000, 5%, 12 months. The only thing that I need to do is the monthly. I need to compute the monthly. Then all this information goes into my amortize command in MATLAB. And then I create my table. This is my table, the schedule table. Got it? So let's run up to there. Okay, so why it's not allowing me to do this stuff? Yeah, I think it's okay. And let's stop here. I don't know why my computer in general is very slow. Okay, guys. So how do we run this program? I need to just copy the name because there are not inputs here. You simply click here in the command window. And let's run. Okay. So if I want to see my schedule table, so it stops here, right? Before the plot. Have you seen that? Before the plot, are you there with me? You know what? Allow me 1 second. Allow me 1 second, guys. Why is it doing this stuff? Yeah, allow me 1 second. What I will do is I think that I maxed my memory in my computer. I don't know what's going on. Yeah, okay, so let me check. Send. So I'm sending you the file that I have so we can go on the same hand, okay? Guys, can you open the file that I have just sent you so we can follow the same numbers, the same rows, etc.
Okay, perfect.
I have just sent you a file. So let's wait for 1 minute. When you receive the file, please let me know. Open the file and let's do this together, okay?
Yeah, I have it up.
Okay, perfect.
As well.
Yeah, perfect. Can you go to 56 and click on the 56 in the same number? So this implies simply MATLAB stop here. Got it?
Okay. Yes.
And then there is a D here. This D here, guys, is just to stop the program, okay? It's not coding, it's simply to stop the program. So just click on 72 also, just to stop again the program there. Got it?
So you want us to click on 56 and 72.
Click, yes, 56, it will stop the machine here.
Okay.
Okay, and then run. run, and you're gonna have something like this. So the program runs up to before 56 and it stops there. Do you have that?
Professor, I get a syntax error whenever I try to click on a specific line. I don't know why.
No. You need to run from outside the command window, in the command window. So that in order to run this program, you need to write the name of just copy the name of the file, of the function in the command window and then enter.
I have the same error if it says can I enable breakpoints because of syntax error and it can't find the function.
Yeah, it
I
won't
don't
allow
know
me to select a specific.
Wait, you need to, can someone share your screen? Give me 1 second. Can someone share your screen? So let me stop sharing. Someone wants to share the screen, so I need to see what's going on.
I can share mine to see.
Yeah, please.
I have to request you. Hold on.
Yep. Ready.
Okay. I think it should be this screen. Can you see my MATLAB?
Yes, perfect. Okay. Oh, yeah, I know. Can you down? Yes, you need to okay, go up, super up. Yes, because you have a B01. You see, your file is called amortization B0 parenthesis 1. So
Yeah.
can you go to the top? Yeah. What you need to do is close this file.
Just exit?
Wait a second. No, an easy solution. Can you go up? Yeah. To the name, just add parentheses at the end of the name, parentheses 01. So we are creating, no, parentheses 1 only, just to be exactly the same. Yes, okay. That's going to be the name of your file. So now save. Yeah, just save. Okay, so now when you call your file, copy all the name, copy the function name. Yes, and copy, go to the, enter. Oh, can you see?
Same thing.
Wait a second. My amortization is good. Can you please type CD?
In the command?
Yes.
CD?
Yeah. So this implies where are you? So you have the program in this directory.
Mhm.
Do you have it there?
Yes.
Yeah, MATLAB. So what is it? It's going syntax error. Where is the syntax error? Because mine runs normally. Can you go down?
If I click on like this, it gives me this.
Syntax error. Okay. Okay, just click OK. Why do you have a syntax error if I don't have? So Bafana, do you have the same problem?
No, Prof.
You, Lauren, you have the same problem?
I did, and what I did is I just deleted the version 1 and then I deleted both files and just re-downloaded the new one.
Oh,
And
yeah.
that seemed to work.
Can you
I'll
do
try
that?
that.
Because it should be something like that. Okay, try that, and then we wait for you
Okay.
for 1 minute. Can you try that,
Okay.
please? You need to close from here. Close this file. No, that one. Exactly. Close it. Then go to the no, go to the where you have your files. In the how do you call it? Windows Explorer. Go Windows Explorer. No, Windows Explorer, not MATLAB, just regular Explorer. You're working? I just see your MATLAB. So delete the files that you have in and then download the last one that I sent you. So there are no two files.
Okay. I think it's just showing my MATLAB. That's the screen I shared, but I'm doing
Oh,
that
yeah.
right.
Okay, got it. But it should work.
Okay, no problem.
Okay.
I'll stop sharing my screen just to
Yep.
give me one.
Okay, let's wait for 1 minute, guys, and then we. So if you see the summary table, guys, schedule table, so you can see my schedule. Do you agree? if you just double click here, go to the command, and here you have all the values. Makes sense? How do we know that this is correct? Because these two numbers at the end are equal. Correct? Makes sense? Do you have these numbers here, guys?
Yes, Prof.
Okay, so if we go to D, just click on D here and continue running. Simply continue. Have I continued or now? Yeah. I don't know why my MATLAB program is really weird. I don't know why I have done. This part here, for example, guys, is useless. It should be the upper part. I don't know why it's doing this stuff. But okay, in any case, it has not created this part here. It is not correct. So now here we go with my figure. So your MATLAB is running fast? Yeah, mine is terrible. So I think I need to simply clean my memory. Do you see that, guys? So here I have this B is my balance. So the balance goes down according to your payments. Do you agree? And my accumulated principal goes up. So I'm paying more and more and more of my debt. And this goes in hand with the blue. This line here simply shows you how much money you are paying. This one here implies how much money you owe to the bank. And the interests here are very low. Because it's only 12 periods, 5%. Make sense? Make sense to you guys?
Yes, Prof.
Okay, so now...
Can you repeat that again? Sorry.
Yes, so
Yeah.
this blue one implies how much money I owe to the bank. As soon as
Yes.
I only have 12 months, so the money that I owe into the bank goes decreasing significantly. The money that I'm accumulating, so basically the money that I'm paying to a bank goes up. So these two eliminate to each other. Do you agree?
Yes.
And the interest rate, there is a red line here. The interest rate is very low. Not the interest rate, the interest you pay are very low because you have only the amount of money is not too much and the number of periods is very low. 12 months. Agree? So now run the following, guys. Let's do something more realistic. Okay, let's close this one here. And you run the following. I want you to run the following exercise. So you are going to buy your first apartment. So now the prices are to the sky. So they are so expensive now. So $500,000, I think you can find a studio in New York, in Manhattan. It's insane. Okay, so let's assume now that you have 30 times 12. So basically monthly payments for 30 years. Let's assume that the interest rate, the annual one, is also very expensive now, right? Let's say 7.25%. So I want you to tell me what is my payment and build your schedule of payment, table of payments. Well, you have the program already, right? So you simply change the data and do the graph. So what is your payment? What is your table and graph? Okay, so I can stop the program. Then what I need to do is very simple, right? I have $500,000. My interest rate is 7.25. I don't know why he's doing this to me. I have 30 years. What? Yeah, guys, you know what? I'm running. I need to clean my workspace. I need to clear my commands. Okay, so 725. Yeah, seriously, my computer is simply blocked. Times 12. Makes sense? So I don't need to make the stop here. I can save this stuff. Yeah, I can make this stop here if you want. And then we run. Okay, so my schedule table, guys. Here you go with all my tables. So I have 360 rows. Do you have that, guys? And you know that this is correct because these two last ones are the ones that are equal. And now let's run. Let's do the graph. What is this doing? This is not correct. This is not correct. So wait a second. So why? This program is driving me nuts. Okay. Okay, so do you have a different figure, guys? Have you been able to run? I don't know why.
I got the same figure as you. I had to uncomment some stuff that we made comments earlier, like the
Yeah.
factor.
Yeah, let me review what's going on here because this is not the right picture. So, well, it doesn't matter. But at least it runs. You have the table. Okay, let me review the code for the graphs because something that is not going in the right way. And I have the plot. What is my payment here? My interest comes from, yeah, my interest. Give me 1 second only. Just I don't want to lose your time. I don't want to miss time. Wait a second. Okay. Let me do something in Excel. Allow me 1 minute, okay? 30 years mortgage. So we said this is 500,000. You see my screen is weird. 7.25%. Yeah, you see that the numbers are completely wrong. So it's 500,000, 7.25, 360. I have this payment. What payment do you have here, guys? In your MATLAB?
1,438
Yeah.
and 20. Yeah,
No,
I have
this is
that.
wrong. This is wrong. So okay, so it's 500. The interest is 0.725. It's correct as we have in Excel. 360 is I'm doing this correct. 30 times 12 is 360, right? Yeah, 360. My monthly interest rate. So you know what? When we have these issues, guys, what we can do is simply let's take a look to the numbers. Because there is something wrong. If the payment is wrong, something is wrong. Okay, I have my PV. I have my annual interest rate. Oh, wait a second. format long. Okay, so allow me 1 second, guys. Good exercise to find mistakes. PV, annual. Okay, good. My periods, 360, good. My monthly, 1944. My monthly is different. It's completely different. So what's going on here? 1 plus over 12. So what is wrong here? I annual. Oh, 1 over periods. No, this is wrong. This is 1 over 12. Do you agree? Guys?
Yeah.
Ah, my MATLAB is driving me nuts. Now what? I'm having serious problems with my computer. This is divided by 12. Then now that was the issue. I'm completely sure this is the issue. Okay, so now let's run this again. Have you seen how do I do the checking, right? So I go step by step. I put the dot somewhere that I can stop. Then I can check step by step what's going wrong. And then I continue moving. Make sense to you guys? So I will do this before here. So let's run this again. Everyone is with me? So you have modified your code. Here is not periods, it's 12. Okay, so now let me check my, yes, my payment now is 333113. So this is like Excel. Are you with me, guys? So all of you have this one here. Guys, are you with me?
I still get the 1438. Do you mind scrolling up real quick
Yeah.
to what you had changed? Okay.
It's simply I changed this one here.
Fine.
Oh, I cannot do anything in MATLAB now. My computer is blocked. But you see that?
Yes. Okay, I'm gonna
Just
try it again.
12. Yeah,
Yeah.
and try again. And then if you just take a look to the payment table, you're going to see that this is correct. Yeah, this looks much more correct. Do you have that? Do you get your 3333.13?
I don't, but that might just be me.
No, you must have it for sure. Can you take a look to the initial values? $500,000, 0.0275. Just use format long also. I did that. Sometimes MATLAB, when you say format bank, cut sometimes. I don't know why. Just use format long just to be sure. Everyone else, you get the results?
Yes,
Kafana? Yep.
yes, I
Karina?
got the results.
Yep. Lauren, very quickly.
Yeah, so I have everything matching with you, but it's still, and I did format long, and it still hasn't updated. Let's see. See, yeah, I have that matching you as well.
Yeah. So, but when you go to the schedule table,
Yes.
something that I call the payment table, it looks like 1/4,000. That's wrong.
Yeah, I still have that.
Can you show me your screen very quickly, please?
Yeah. Okay. I'll share right now. Share. Um, yes. All right. So I'm here right now.
Yeah.
Do you see? Does it come up?
No, it's
Yeah.
not coming
Okay.
yet. Yep.
Okay, 500,000.
Okay. 500,000. Yeah. 30 times 12.
Yeah.
Yeah. Yeah. Can you wait? Yeah, because you have the old version. This is not the
Oh, so factor
no.
onward should not be included. Like up to
No.
here should be.
Yes, up to there. Delete or comment
Okay.
out. Just right click
Okay.
comment.
Got it. Okay.
Yes. Can you run that?
Yeah.
You need to copy. No, save first. You need to save.
Oh,
No,
here.
save.
Okay.
Otherwise,
Okay.
it will not consider the changes.
Got it.
Yeah. Can you
And
run?
then run it. All right.
Yeah.
And then here. Payment
Yeah.
to.
Okay. Go to. Yeah, exactly. Just put your mouse.
Yeah. Okay. That was
Oh,
it.
yes. Great. So
Yes,
now
thank
we are
you.
all on the same page. Perfect.
Yes. Thank
Perfect.
you.
Perfect. So now let's go. Let me show you my screen. Now, do you have I want to continue. I want to do the graph. Oh, here we go. Yeah, that's more reasonable. Do you see, guys? So my blue is my payments. It got decreasing in time. Take a look to what happens with my principal. My principal at the beginning is slow, goes slow, and then catches up. But who's the killer? Interests. You see? So that's why, guys,
Yes.
recommendation when you have a loan, when you are young, and you prefer to have your money in saving account. Of course, you need to have some savings. Do you agree? Just for something goes wrong. But everything else, kill your loan. Do prepayments, do prepayments, do prepayments. Okay, because this one here kills you. It really. You know, we were talking yesterday in one of the classes, and basically, if you don't do anything else, you're working for the bank all your life. Okay, take a look too. Just take a look. Let's do the. I will do the Excel here. Take a look, guys. You can do this also in MATLAB. From the $3,000 that you pay, how much goes to the bank? 2,900. How much goes to against your loan? $400, guys. That's a pain. Just sum all this money here that you take a look to how much money you pay. You pay 699, so you pay more than double the value of the house. The way you reduce this one here, and this is going to be part of your assignment, not now, you need to have more techniques, is allow your program to create prepayments. You know, I have $10,000, boom, go prepayment. So you're gonna see that the line of the interest rates, how this goes very dramatically, goes down significantly. Another trick for you guys that in real life you need to do, and this works amazingly good. If you can pay the bank instead of monthly, pay every 2 weeks, this line here changes dramatically. Changes dramatically. And the bank can accept that. By law, you can tell them what is the frequency of your payment. Make sense? So try to pay as much as you can, as fast as you can. That's the commentary. Make sense to everyone?
Yes.
Okay?
Yes.
So you have your file, you know how to read your file. So now let's continue, guys, working on a lot of new language. So let me clean this stuff here because currently I don't have memory. Okay, so let me stop my program. And so let's talk a little about, guys, things that we always use. Strings. How do you call it? Text. Okay, so let's write, for example, let's call this T, and I will write text. When you do the apostrophe, so MATLAB is going to understand, it's going to accept this one here as a vector. That's what is interesting. How about let's write this character string. Okay, so MATLAB considers characters or text like numbers. Okay, this is a vector for MATLAB. So imagine, guys, I want to just capture character, and I will call this U. So how do I capture character? What vector I'm using? I'm using T. What I'm selecting from T? Well, we need to count. 1, 2, 3. Spaces are also counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So from 16 to 17, 18, 19, 20, 24. Yeah, okay. So let's do 16 to 24. Do you see? So for MATLAB, text is exactly the same as vectors. What I can do, for example, is I can can I do this? U1 equals U n minus 1 to 1. So what I'm doing there, guys?
Yeah, swapping the way.
So we're flipping the things.
Flipping, yes.
Make sense? So it's exactly the same like vector. So now, do you remember the ASCII code? Because MATLAB works with ASCII code. So every single letter, character, or form, or whatever has an ASCII code attached to that. So let's define, for example, guys, I don't know, let's say S equals, A, B, C, D, A, B, C, D, E, F, for example. Okay, so what is the ASCII code? What is the numerical representation of this one here? So I will call this M. And in order to convert text into numbers, you simply use absolute. The absolute value is the same command, abs of S. And these are the ASCII codes. There are numeric codes. Okay, so when you have text, you want to transform this into numbers, you use abs. Now, if you have numbers and you want to transform numbers into text, what you do is, let's call this M1. What you use is set string of M. If you do that, we go back to letters. Make sense? Now, guys, it is very interesting because MATLAB coding was a simple code that was used during, I think this was what was the last war, Korean or the Vietnam War? I think it was Vietnam War. So the logic of transforming letters into numbers was used in the past for coding, okay, for encryption. So, for example, let's do a simple example. So let's do, this is the secret message that I want to tell you. Got it? And what I will do is I will create a code. It's going to be G plus 5. Okay. And then what I will do is G2. I will say set string G plus 5. Do you see? So this was what was transmitted. And then in a different channel, they were saying, for example, hey, it was very nice to see you, or we're going to see you tonight at 5 p.m. in the cinema. Okay, good. So the code was where in this wording, there was the code that helped me break this code. What was the code there, guys? Or see you tomorrow in the cinema at 5 p.m. So what is the code?
Oh, 5?
The
Like
5.
-5, yeah.
Yes, and so someone that knew that, and so there were a mixture of these ones. So, I know. So the code is 5. So what I will do is, I know what I will do is G3 is going to be equal to G1 minus 5. Okay, so what I can do is directly set a string of G minus 5. Here we go. Do you see that? So you can play with adding numbers, subtracting numbers, and you can create something fun. And this is part of your assignment number 2, I think. You're going to create a code, and you're going to give us a clue. And then we need to determine with the clue, what are you trying to tell us? I had one student that wrote, I think it was 150 characters. And this was simply a reading, very simple reading. But he gave us a code in such a way that you tell MATLAB the code, and MATLAB was able to read from different pieces of the equation, and it was a very simple and beautiful message to you. Okay, don't do that. Don't stress with that. If you have time, do it. Otherwise, just do something simple. Got it? Make sense? Okay, so we have another command that is very important. So let's assume, guys, that I have X is going to be defined I will define the following. I don't know if I gave you this one here already in the help. Yeah, I send you also one file that is the help. Can you help me with that? Just copy the first one here. Oh my.
Decoration करना है.
And then I want to see what is X. Sometimes, guys, when you use data from the World Bank or the IFC, these guys give you the data in this format. Year equals 2014. Okay, and I cannot do anything because this is text. So first of all, I need to transform text into numbers. First of all, I need to get rid of YY. Correct, guys? So you can see the who's. Look, who's, what was the name? X is a character. So we need, first of all, let's get rid of YY. So how do you do that, guys? Let's call this Y. I just want to have the years. So I want, Y is going to be take from X positions 2 to the end. Oh, sorry, what I have done. From X, what is my X? Oh, yeah, sorry. From X, all rows, 2 to the end. Is 2 to the end? No, it's 3 to the end, right? Guys, are you with me? So this is the data. So I want all columns, all rows, but just I want to take from position 3 to the end.
Ah.
I have the 2014. But let's do who's again. Why? Okay, Y only has the years, but it's still a character. So I cannot do anything with this character. How do I transform a character into a number? Okay, and that's crucial. So let's call this YY, and the command is going to be string to num. Of what? Of Y. Now, whose? YY is a double, so this is a number. So this is what we have, string to num. Make sense? So string to num is always crucial, guys, because sometimes we want to transform characters that we want them to be doubles, so numbers. So we need to transform them, string to num. This is one useful command. We're going to use this command later by a lot. Make sense to everyone? Okay, so
Yes.
now let's go into timing. We always use time for everything. So if you do today, wow, what is that? Do you remember Excel also has something similar to that? The dates, indeed, they are numbers. Okay, so today for MATLAB this is today, but I don't know what is this today. The day you transform a number from MATLAB into something that we can read, the command is going to be date string. Date string today. Okay, sometimes when you run a program, guys, you want to check the exact minute, second, etc. that you are. So what you do is now. Okay, again, I don't understand now. So it is date string now. Agree with me or not? So today is June 3rd, 2026, and the time that we have done this stuff is 7 p.m. 58:28 seconds. Okay. There are some instances, guys, in where you need the specific days. You know, I want to know the specific dates. Let's say the last Mondays of every month the last Mondays of every month during 2026. Something like that. I just want to know the specific dates of the last Mondays of every month in 2026. So let's call this Mondays. Okay, this is our name, Monday dates. And the command is going to be last week date. Last week date. And then what we enter is, so 1 is always Sunday. 2 is Monday. So I'm interested about Monday. I want this from 2026. And I want this for every single month. So 2 is I'm interested about the Mondays. All the last Mondays, that's why it's L week of 2026 for all the months. Oh yeah, of course. Again, I need to do the date string Monday dates. Always, MATLAB is always going to communicate with you with numbers. And the way you transform numbers into dates is date string. Date string. Okay, let's do a couple more and then there are tons of them. You just do help dates. The most important ones are these ones here. So let's do remember Martin Luther King days. Let's say days. Okay. This is going to be N week. So specific weeks is N week date. When is the date that they have? I think it's the
Like January 20th or something.
yeah, it's the third. Yeah, that's right. It's the third week. Okay, it's the third week. What day is that? Monday, right? Correct?
Yeah.
It's the third week. It's Monday. Now let's say from what years? What years do you want? 2016 to 2026. These are the next day, and then we want January. Do you agree? So this is going to be the third Monday from 2026 to 2016 to 2016 to 2026. And what I want here is January. Third Monday, 2026, 2016, 2026, and I want the January, the month January. We can do here again date string directly. Just not to be doing this all the time. Here we go. And why these are important, guys? Because these are New York Stock Exchange and NASDAQ are closed in these days, for example. Yeah, and the last one, what we can do is holidays, okay? New York Stock Exchange holidays. And the command is called holidays. So what holidays we want? So I want holidays from what? 1 January 2020 to when? Let's say 31 December 2026. Yeah, let's do for this year only. January to December 2026. Oh. So we can do this directly. Data string. Here we go. So these are the holidays of New York Stock Exchange, guys. This is Martin Luther King, New Year's. I don't know, what is it? 16 is what? President's Day?
Yes.
September 7th, this is when we start classes. What is this September 7th? I always forget that.
Labor Day, I
Labor
think.
Day.
Yeah.
This our day. Yeah, Christmas. And what is this one here? Oh, Thanksgiving, etc. Makes sense to you? And of course, this changes according to the year. Makes sense to you guys? We're gonna be using that for payments. You're gonna see. Let me see. Yeah, we can do. Yeah, bonds. Yes. We need bonds. Okay, so let's work with bonds. We stop because we have done really good. Now I have 4 PhD students that are doing the comps. So okay, so let's do bonds. First of all, let's take a look to the logic of a bond. Let me save this one here. Class slide 2. Yeah, so let's go into a new one. So let's take I will give you the brief description of a bond, guys. Okay, so take a look to the bonds. The bonds, the cash flow of a bond looks like that. The most simple example. Okay, so the bonds, guys, have the following constitution. So these guys are called coupons. And the last one here, you receive the coupon plus the face value. Hey, Bafana, I think that you are with someone is talking in your.
Oh no, sorry.
No problem. And the face value. And so this is the price of the bond. Okay, the coupon, C is equal to the coupon. And we have a coupon rate. And then we have something, guys, that is called the yield to maturity. This one here is called yield to maturity. Okay, so let's do one example. Let's say that the face value, let's call this face value. My face value equals 1,000. Let's assume that my coupon rate equals, let's say 5%. Yeah, let's do 5%. Okay, per period. Or I can say, yeah, I can argue quarterly. Let's do this quarterly. And then okay, so with this one here, guys, what is my C? Oh, coupon payments are also quarterly. Something simple. Okay, so it's too much. Let's do 2% here. Let's do 2%. So what is the meaning of that? Every 3 months, so it's going to be 3, 6, 9, 12, 15, 18. What is going to be my coupon? How much I will receive? So my coupon equals what? It's going to be simply my face value that multiplies my coupon rate. So this is equal to 20, right? So this implies that I will receive 20, 20, 20, 20, 20, And here I will receive 20 plus my face value of 1,000. Make sense to you guys? I don't want to complicate your life at this point. I just want to do a straightforward one. I have my coupons that come per period. And the only thing that I need to know, guys, is my P, correct? This is a cash flow. How do I compute my P? It's discounting everything. Do you agree? I simply need to move this 20 to period 0, this 20 here, this 20. Everyone goes to this period. Correct or not? Yes. So what is the variable that I need to make the discount? I need an interest rate. This interest rate is called what? It's not the coupon. The coupon rate is simply to compute the coupons. The one that you use for discounting is this one here. Got it? And this one here, guys, the yield to maturity depends on what? Depends on the market. So this implies that sometimes the yield to maturity can be larger than the coupon. Sometimes the yield to maturity can be equal to the coupon. And sometimes the yield to maturity will be smaller than the coupon. So this implies, guys, that the price is not necessarily going to be equal to the face value. The price is going to be equal to the face value if and only if here, the price equals the face value. When the yield to maturity equals the coupon rate, sorry, it's the coupon rate, both of them are going to be the same. Now, if you see in a graph here, guys, we have something that looks like that. When the yield to maturity is larger than the coupon, we have a discount bond. Do you agree? Because we are discounting at a higher interest rate, so these numbers are going to be smaller, and my price is going to be smaller. So I have a discount bond is here. So you are going to pay less than the face value, $900, for example. Now, if the yield to maturity is smaller than the coupon, so what happens is all these cash flows here are going to be higher. When you discount them for a lower number, so that the price is going to be on top. So this is what is called a premium. This one here is premium bond. Make sense to everyone? So we're going to start working with this stuff.
Quick question. That
Yes.
applies to the yield to maturity is greater than the coupon rate. Which one does this
one,
apply to?
discount.
Okay.
Here is the
Yeah.
yield to maturity greater than coupon rate. And here,
Okay.
yield to maturity is smaller than coupon rate. Yep.
And this whole graph represents payments?
No, this is
Okay.
no. This
Okay.
represents the price. So
Okay.
this one here,
Okay.
this one here.
Okay.
Because we have every single piece of information, do you agree?
Yeah, we do.
When you buy a bond, they give you the coupon rate, they give you the face value. So you can compute
Yes.
this one. So you can compute everything except the price.
Mhm.
And to compute the price, you don't take a look to the coupons. You go to the market and you see the yield to maturity. This is
Got it.
publicly available, guys. It changes dramatically intradaily also. Okay, it depends on which industry, depends on how the interest rates are provided, are given, depends on unemployment, depends on everything. Depends on the war with Iran, depends on so many things. The yield to maturity really changes dramatically. Okay, guys?
Sorry, just to make sure, it's like yield to maturity is greater than the coupon rate. That means we're purchasing at a discount price.
Yes, Exactly.
Okay,
Why?
got it. Thank
Because
you.
remember, if you discount everything by 2%, you see this number here, that is exactly at the coupon rate. What is going to be your value here is going to be exactly to your face value by construction.
Okay.
Okay, so if the yield to maturity is 2%, exactly the same as the coupon rate, like this one here. So par, so this one is called par. This one here is par. Okay, guys?
Yes.
Okay, so the first thing that you need to remember, guys, is that even if you say every 3 months, you normally need to have the specific date of payment of the bonds. Got it? So normally you say it's going to be the last day of the month. But what happens if the last day of the month is a Saturday? So you need to move it to Monday, correct? And so that's what we are going to be doing. So the first thing that we need to do, guys, is need to identify my dates, my payment dates. Got it? So let me go back. Okay, copy this one if you want to. Let me save this one here. Where is this one here? Class 3. Oops. So let's write here, guys. So I'm doing bonds, okay? We'll call this pay dates, okay? And this is going to be cash flow dates. And let's assume that I want to start, I will issue this bond on 25 May 2026. And this is going to go up to 31 December 2027. I will pay quarterly, so 4 is quarterly. So the basics, I will tell you what is the basis. Where's my... Something that is called a basis, guys, is how many days do you consider in the year? Okay, for MATLAB, 3 implies consider the 365 days in a year. There is another one, I think it's 1 or 2, that considers only 360 days per year. Okay, the common one is this one here, 3, the number 3, that considers 365 days. So this is the 3, and 1 for MATLAB implies the last day of every single month in the quarter. Okay, remember, guys, you use the help menu to see all this stuff, okay? So this is when we are going to sell the bond for first time, until when is going to be paid the coupons. This 4 is, I will pay my bonds quarterly. So it's not every 4 months, it's quarterly, so every 3 months. This one here is the basics, so I want to use 365 days. And this one is end of the month. No, oh yeah, of course. Sorry, guys. Is this one? Is this one? Oh, and then if we want to have the, how do you call it? What we can do? Let me delete. So I can do this directly, right? Dates string. Dates string. And let's call this pay dates. I know why I wrote this incorrectly. So these are my pay dates, guys. So I will be paying the first coupon on June the 30th, September 30, etc., etc., etc. So what I'm doing, just don't get confused, is first determine what what are the exact dates here? Okay, what days are the exact dates here? That's all what I'm doing. So now we need to go and to see the price, to see what is the price of my bond. So let's determine the price of my bond. So let's assume that the yield to maturity, let's assume equals 3%. Make sense, guys? So let's assume equals 3%. Let's assume that my coupon rate, we said it was equal to 2%, right? Agree, guys? So we
Yes.
have said that the settlement, let's call this settle. These are names. It's going to be, my settlement was date num. I need to transform my date into a number. This is my settlement date. So I need to give this to MATLAB in number way. And the maturity, we said that my maturity was equal to date num. Date num, guys, is simply to transform the dates into numbers. It was December 31st. What else do I need? I think with this, I'm okay. So let's do P bond, let's say. Okay, it's going to be equal to bond price. The command is bond BNB price. Of what? Okay, first the yield. What is my yield? Yield to maturity. The coupon rate is coupon rate, something I call coupon rate. Then we have the settle and the maturity. Where is my settle? And my maturity. Here we go. This is your price. So what is this price, guys? What is 98.41.45? Hey, wait a second. I haven't given the face value. Yes, because this number here, guys, is simply represents 98.45% of whatever face value that you have. Make sense? So if my face value is $1,000, what is the market price? Guys, if my face value is $1,000, what is the market price of the bond? Yes, Bafana.
Is it 98% of that
Yeah,
1,000?
so 984.5. Do you see that, guys? So the price is always
Yeah.
presented in percentages of what? Of any face value. Make sense to you guys? So this implies that my bond, if I continue doing this example here, if my yield to maturity, remember here was my yield to maturity was 3%, that is larger than my coupon rate that is equal to 2%. So my price is going to be 98 what? 98.45. 98.45. Do you agree? Can you run the same exercise, guys, now with a yield to maturity equal to 1%, smaller than C, equal than 2%? So what is my new price? And then run another one that yield to maturity equals 2%, that is equal to your coupon rate, that is equal to 2%. So what is your price? The only thing that you need to change here, guys, is to yield to maturity, right? This one here. Now it's 0.02. Oh, no, 0. I said 0.01, right? Or 0. What I said? I'm tired. 1% first. Well, and then the only thing that changes is that. Where's my new bond price? 101.58. Correct? Do you get this number? Yes or not, guys?
Yes.
We do, Prof.
101.58. So what is the meaning of that? So if my face value equals $1,000, what is the price now? $1,000 is the face value. What is my price? 1,015. Agree or not, guys?
Yes. Yes.
So this one here is called discount. This one here is called premium. And what happens when yield to maturity equals 2%?
The bond price is 100%.
Yes. Have you tried that?
Yes.
100%. This is what I was telling to you here, guys, in the graph. Okay, questions? Okay, so next class, guys, we're going to start working really hard on relational findings and just working really hard now on programs. Can you please review everything that we have done up to now? Remember, this is a language, okay? Programming is a language. Have you learned any other language, not English? What other language do you speak, guys? That you have learned, not your native language. My native language is Spanish, so I learned English, so I needed to learn the words. Do you agree? And it was a pain in the neck remembering words. And once you have the words, what do you do? Grammar, and then phonetics. I'm terrible in phonetics. I'm good, I think, in grammar, but phonetics I still have issues. But it's the same with MATLAB. Okay, so you need to learn words, commands in order to start building up more things. You're gonna see, guys, next week. You're gonna be surprised with the type of programs you're gonna be working with. Okay. But for that, in order for you to be really catching up, you need to study what we have done up to now. Make sense? So you have 2 assignments. Do assignment number 1. If you can try to do something about assignment number 2. But we haven't finished yet. So number 1, yes, for sure. Number 2, a little. Got it? So we stop
Okay,
here
Prof.
for today. I prefer your guys to catch up quickly. I will
Okay, Prof.
I think I will have the recordings. Normally they take several days. So I will request the recordings tomorrow for forum, and then hopefully we're gonna have them. And so I will make them available in YouTube. Normally post them on YouTube, and so you can go and see.
Thank you.
Okay.
Okay? Yes.
When is the first homework due?
Monday. No.
Monday?
Yes, we meet Monday. Yes, Monday.
Okay.
So what
And
you
then
need
the
to do, guys,
yeah.
is send me the MATLAB. So what you do is, remember, we haven't done M files yet. Okay? So what you need to do is question number 1, just copy your MATLAB command. So I can copy paste from Word. Just use Word. Okay, it's much easier for me. If I have some comments, I can write them. Just what I do is simply copy paste your answer in MATLAB, copy paste in MATLAB, run. If it runs, you're good. If it doesn't run, then I ask you questions.
Okay,
Makes
thank
sense?
you.
And
And then
later, what you're gonna
yeah.
be doing is simply sending me the M file. That's all.
All right, got it.
Got it?
And then the homework 2, just leave
Yes.
it be. Don't like
Try to do as
just
much
try
as you
it.
can, but
Okay.
no, you don't need to
Okay.
do it.
Okay,
Okay?
cool. Thank you. Yes.
Perfect. See you guys. Take care.
Awesome. Have a good night.
Bye bye. Have a
Good
good night.
night.
Bye, guys.
Have a
Take
Bye.
care. Bye.